This paper presents VINECS, video-based neural character skinning, the first fully automated approach for creating a fully rigged character with pose-dependent skinning weights, which can be solely learned from multi-view video. Traditionally, skinning is a manual process that requires expertise and often involves iterative manual editing. Along with that, most existing automatic skinning methods, either example-based or data-driven, only predict a static set of skinning weights, which often results in artifacts for poses significantly different from the static template. Recently, neural SDF-based methods model pose-dependent effects as dense deformation fields. However, most of these methods require a temporal set of 3D scans of the subject, which could be hard to acquire. In addition, all these works assume the skinning weights are fixed. Thus, learning pose-dependent skinning weights remains an unsolved problem, especially when only multi-view imagery is given. This paper addresses the challenges mentioned above and introduces the first approach to learning a fully rigged character with pose-dependent skinning weights from a multi-view video, without any 3D supervision. For training, all our model requires is a calibrated multi-view video. It then recovers the skeletal pose using markerless motion capture. Our method combines the explicit mesh-based and the implicit modeling. In the first step, we extract an explicit template from one frame using News, a state-of-the-art multi-view mesh reconstruction method. To supervise the training, we obtain an initial set of skinning weights and human parsing by running state-of-the-art automatic methods. To predict the skinning weights, we introduce a coordinate-based MLP, called SkinNet, which takes the pose parameter and any 3D coordinate as input, and outputs the skinning weights at that location. With the predicted skinning weights, the template mesh can be animated using linear blend skinning. The SkinNet can be weakly supervised in an analysis by synthesis manner. After projecting the animated mesh to the image space, we apply a silhouette loss and a differentiable rendering loss. However, during our experiments, we found if we only use the static texture extracted by News, the network can hardly obtain an optimal convergence. To address this issue, we propose a neural appearance field to predict auxiliary appearance to supervise SkinNet. The neural appearance field consists of two components, albedoNet and shadowNet. Both are coordinate-based MLPs. AlbedoNet estimates a static albedo field, whereas shadowNet predicts a multiplier accounting for the shadow and shading effects. The latter is conditioned on the human pose and the view and the normal directions. By multiplying the output of albedoNet and shadowNet, we obtain the final pose and view-dependent color at any 3D point. In addition, we apply several regularizations, including the Laplacian loss, the skinning regularization, and the part-wise regularization, which ensure the geometry is visually plausible. After training, given a new pose, our model can predict pose-dependent skinning weights, which then generate a high-quality 3D human mesh after linear blend skinning. Next, we show more qualitative results. All skeletal poses here are from our test set and were not seen during training. Note that the meshes animated by our pose-dependent skinning weights reasonably overlay the ground truth video. Also, our results deform naturally under a large variety of poses. Last, since VINECS predicts a skinning weights field, we can also animate the template mesh at different resolutions without requiring any retraining of networks. Next, we compare our method to several previous works, including Pinocchio, RigNet, Scanimate, and Scanimate without pose-aware shapes. We also visualize the error computed between the prediction and the ground truth scan. Our method consistently shows the lowest error and has the least amount of visual artifacts. To validate the effectiveness of the key factors of our method, we compare our final method to the initial skinning weights, the static skinning weights optimized using our supervision scheme. Training without the dense rendering loss and training with news appearance. We observe that all our design choices gradually contribute to the final result. Although we propose the first method for learning post-dependent skinning weights solely from multi-view videos, our method still has some limitations. Here, we can see that the post tracking is actually inaccurate, which may potentially harm our skinning weight learning. We believe a joint consideration of rigging, skinning, and post tracking could help to further improve the quality of the 3D animation-ready characters and would be an interesting direction for future work. In summary, we propose the first method for creating a fully rigged and skinned character solely from multi-view video without any manual processing that outperforms previous methods and has the least amount of visual artifacts. Thank you for your attention.